Welcome, everyone. We are so happy to have you all here. Please feel free to grab some coffee and juice and pastries. It's okay to eat and listen at the same time. So I want to encourage you all if you want to stay healthy and strong. Welcome, everyone, and esteemed guests, and of course, our participants to the 30th anniversary of the Massachusetts Undergraduate Research Conference, which we all love to call MassURC. It is my great pleasure to be here with you all today as we gather to celebrate the significant milestone in our statewide academic community. I am Dr. Mari Castaneda. I'm Dean of Commonwealth Honors College. I'm also a professor in the Department of Communication here at UMass Amherst, and I extend my warmest greetings to each and every one of you who has joined us here for the keynote, both in person and online. We're also streaming this today for the 2024 Massachusetts Undergraduate Research Conference. I'm absolutely thrilled to introduce you to our distinguished keynote speaker for this year's event, Dr. Lamia Karim. Dr. Karim is an associate professor in the Department of Bioengineering and holds the esteemed position of the Director of the Office of Undergraduate Research at UMass Dartmouth. Her dedication to fostering academic excellence and empowering aspiring scholars is truly commendable. Today, we have the privilege of delving into Dr. Karim's keynote address titled Turning Your Failures into Successes, a Scholar's Journey Through Research and Perseverance. Dr. Karim's insights into the transformative power of perseverance and resilience promise to share us all. Oh, I'm going to give just a moment for folks. We're live streaming right now. as you all can see, folks coming in. Yeah. Awesome. Drawing from her own remarkable journey, she will share invaluable lessons on embracing failure as a stepping stone to success and the profound impact of undergraduate research on personal and professional growth. Dr. Karim's extensive academic background, including her BE from Stony Brook University and PhD from Rensselaer Polytechnic Institute, underscores her expertise in biomedical engineering. As a postdoctoral research fellow at Harvard Medical School, she hones her skills and expertise before embarking on her illustrious career at UMass Dartmouth. Her dedication to advancing research in molecular and cellular processes related to bone health exemplifies her commitment to academic excellence and student success. As we eagerly anticipate Dr. Karim's keynote address, let us reflect on the importance of perseverance and resilience in our own academic journeys. And I'm confident that her address will ignite thought-provoking conversations and inspire us all to reach new heights of achievements. And we will have about 15 to 20 minutes for Q&A, for feedback, for reflections and thought after her presentation. MassURC began 30 years ago exactly because so many of our students across the state are engaging in thought-provoking and interested in innovative research and projects and creative practices as well. And so it's really exciting to have you all here and really exciting to have Dr. Karim present her lecture as well. Before I end, I want to give a big warm thanks to the many people who made this keynote and MassURC possible. Thank you to the Williamson Lecture Funds, to all the staff and faculty and students in Commonwealth Honors College and across the university who have made this conference possible. Our statewide campus contacts who are key for making sure that our students from across the state are participating and engaging in this really important conference, which I want to note that it's one of the very few across the United States. Very few states actually have statewide undergraduate research conferences. So it is a very, very unique place that we have here in our state of Massachusetts. I also want to thank the Massachusetts Department of Higher Education, the Massachusetts State Universities Council of Presidents, and the Massachusetts Association of Community Colleges, all for their support, financial and the fact that they really feel committed to this particular conference every single year. So thank you all as well for your presence here today as well. I do also want to take a moment to also thank and acknowledge the Indigenous communities whose lands we stand on and who have allowed us to be in this space here today, given the historical presence of Indigenous communities in the areas. The University of Massachusetts Amherst also acknowledges that it was founded and built on the unceded homelands of the Pocumtuck Nation on the land of the Noatak community. And so we begin with gratitude for nearby lands and waters. We recognize these lands and waters as important relations with which we are all interconnected and depend on to sustain life and well-being. The Pocumtuck had connections to these lands for millennia. Over 400 years of colonization, when Pocumtuck peoples were displaced, many joined their Algonquin relatives to the east, the south, the west, and north. That includes Mashpee and Equina Wampanoag, Nipmuc, Narragansett, Mohegan, Pequot, Mohican communities, and Abenaki and other nations of the Wabanaki Confederacy. These Native peoples still maintain connections and relationships of care for these lands today. We also acknowledge that the University of Massachusetts Amherst is a land-grant university. As part of the Moral Land Grant Act, portions of this land from 82 Native nations west of the Mississippi were sold to provide the resources to found and build this university. As an active first step towards decolonization, we encourage you all to learn more about the Native nations whose homelands UMass Amherst now resides on, and also the indigenous homelands on which you live and work. We also invite you to deepen your relationship to these living lands and waters, which is so important for us to recognize the fact that we're not here alone, and we're here and building on the resources and communities of people that came before us and are still here with us today. So once again, welcome to the 30th anniversary of Massachusetts Research Conference. And so without further ado, I would like to bring up Dr. Karim to the podium. So help me welcome her with a warm applause.
Thank you so much for a very generous introduction. I'm very honored that I was asked to speak here today. So I'm currently in my 8th year as a faculty member, only 1 year into being the director of the Office of Undergraduate Research. And today I'd like to talk to you a little bit about my journey in research. And I know the talk title says, turn your failures into successes. So I'm going to start by sharing one of my most recent failures. And that has to do with this talk. So the very first version of this talk that I made, I decided that I was going to rehearse it with my husband and my sisters. So I sat down, one of them is an engineer, one of them is a writer. And I barely got through the first 10 minutes, and they both looked at each other, and then they looked at me, and in much nicer words, they basically said, this talk is horrible. Okay. However, they did rip it apart a little bit, and they gave me some really good feedback, and I was able to use it to make what I hope is a slightly better talk. So I realized I was doing something new. I've become a pro at giving scientific talks, but I've never really gotten the opportunity to share the story and how I came to do this science. So I'm very excited to share that story with them, especially with all the students who are actually sitting here. So to give you an idea of the research that I currently do, I study bone health and diabetes. It's a topic that I'm very personally interested in because I have close family members who have diabetes. And just this, 6 months ago, I myself had gestational diabetes, which is diabetes while pregnant. So this disease is rampant all across America, all across the globe. And if you look at this map, basically what it shows is that over the last 20 years or so, the prevalence of diabetes has slowly just been increasing all across the country. So it's a disease that affects about 38 million people, about 1 in every 10 people, and 1 in 5 people, they're just walking around not even knowing that they have diabetes. So they're undiagnosed, they're untreated. So it is a very major health problem. Now, you likely know someone who has diabetes. And if you do, you know that these patients suffer from all sorts of health complications. Difficulty with their eyesight, they have kidney problems, they have heart problems, you name it. Chances are a diabetic has that problem. What you might not know is that diabetics also are very likely to break their bones, okay? So our goal really is to study what is going on in the bone that makes it break, and why is it that it breaks so easily, specifically in diabetics. And more specifically, we study what those high sugar levels in diabetics, what those high sugar levels do in bone at a very small nano and micro scale level that ultimately makes those bones very big. Now, this seems like a very, very specific thing to study, and it might appear that maybe I study this because I've always had some kind of a passion or vision of solving a health problem that affects my family, but it really didn't start that way. I started off exactly like most of the undergrad students in this room. I was an undergrad student working in a lab. And to be honest, I really didn't know what I was doing most of the time when I was working in the lab as a student. And most of the time I was messing up. And I didn't realize it at the time. And I understand this now in hindsight, but all those times I messed up or things didn't exactly go the way I envisioned it, those experiences were exactly what brought me here today. So this makes me think of this quote by Thomas Edison: "I haven't failed, I've just found 10,000 ways that won't work." Okay, it sounds cliche, but there's so much you can learn from things going wrong, or often just feel like you're not really sure how things are going. I'm not really sure what I'm doing, but there's a lot of value in that. You can learn a lot of things. So how did I get here? These are some of the key institutions where I had the experiences that shaped me as a researcher. And I'm going to share what my path was like, what I learned from it. And most of the lessons that I learned, I don't think that I really learned it then. I have learned lessons from those experiences over a very long period of time, years, in fact. Just a few days ago, I realized that my undergrad research experience started in the 2003-2004 academic year, and right now we're in the 2023-2024 academic year. So the lessons I've learned, I literally learned over the course of 20 years. So let's go backwards in time. So before I became faculty at UMass Dartmouth, I was a postdoctoral researcher at Beth Israel Deaconess Medical Center in Boston. And as a postdoc, I worked in Dr. Mary Bucksein's lab. She was and still is an amazing mentor. In fact, this is a picture of us from one of the days she won a mentoring award. So she runs a lab full of biomechanical engineers, biologists. And when I was in her group, I got a chance to work on clinical studies. So I was interacting with patients, I was walking them through all the work that we do. I was basically trying to convince them to donate a chunk of their bone to me so that I could study it. Okay. And then after that, I would run around behind the surgeons who worked on those studies with us to collect those bone samples that they would then get from those patients during surgery. So this was the very first opportunity I had to work with patients, and specifically work with patients in a disease that I thought was interesting. Before that experience, I was a grad student at Rensselaer Polytechnic Institute. It's an engineering school about 2 hours west of here in upstate New York. This is a picture of the biotech building where my lab was located. It was a beautiful building. It was brand new at the time I started school there. So while I was there, I worked with Dr. Deepak Vashish, who was a mechanical engineer, happened to study bone. In his lab, I got a chance to learn some of the technical skills that are critical to our field. So how do you test and do fracture testing? How do you do high resolution imaging? Learn some biochemistry methods. Prior to my time in grad school was my time in undergrad. And I would say that these really were my foundation years in understanding what research would look like. I was a college student doing research in Dr. Stefan Udex's lab. And while I was there, I didn't really know where my interest would end up going at some point. But this was the time where I first learned that it was a thing that you study bones. I never really thought that was a thing that anyone could study. Why would you study bones? And during my 4 years there, I learned one single technique really, really, really well. And that was this technique called microcomputed tomography imaging. It's basically a type of really high resolution imaging, and it's the very first thing that you would do when you had a bone experiment. First, image the bones. Second, you break the bones. And then you would relate what you see when you break the bones to what you saw in those pictures. And this figure actually happens to be one of the first set of pictures that I had helped take at that time. I actually had to dig through all my emails from like 2003, 2004 to dig this picture up. And I remember being very proud of it because I had spent so much time learning how to do this thing. So essentially, you can see how each stage contributed to my very niche topic. And as I worked backwards, what happened was that I learned broader and broader skills that 20 years later, I've now finally put together to study diabetic skeletal. So at each of these institutions, each of those stages in my research career, I had a series of failures or things that didn't quite go the way I had first imagined. And despite those failures, I learned something. I took away something valuable that could help me at the next stage in my life. And so what I'd like for you to take away from this talk today is that there really is no improvement or advancement in research and learning in general without failing and just trying things out first. So I'm going to share some of those many failures. I have plenty to share. What ended up working out and what lessons I learned. So as I mentioned, those foundational years in research as an undergrad student, they all start at Stony Brook University, where I went for college. And it's a school that's actually not very different from UMass Amherst in that it's part of the state university system. It was one of the flagship schools. We had about 25,000 students there. So a lot of it reminds me of this campus. While I was there, I majored in biomedical engineering. How did I pick that field? I just kind of mushed together my interest in biology and physics and medicine. And I pursued that field, not knowing too much about what it might be like. The name biomedical engineering just kind of made sense based on my interests. So, let's do it. Let's give this a try. Now, while I did research here, this is the building that my lab was located in. It was not a glamorous experience at all. I've worked on a bunch of projects. One particular project that comes to mind was we had to embed a bunch of bone samples in cement, okay? Just so that you could set it up for a very specific type of mechanical testing. And I came up with this brilliant plan. I'm 18, 19 years old, my first year of undergrad. And my brilliant plan was like, let me line this entire lab bench up with beakers, mix the cement in, like one after another. Like I set up an assembly line of sorts. And it didn't occur to me at the time that if you mix cement in a glass beaker, you're basically going to ruin that beaker. You'll never be able to wash it out. So just as I was pouring cement in, poured them in all of them, a graduate student says, that once the cement dries, that you'll never be able to wash it out, right? So I look at him and I look at all these beakers and I realize that I didn't just ruin one beaker, I ruined like practically the lab's entire stash of beakers all at once. So that was one memory that came to mind. I mistakenly ruined bone samples. So this is an example of what one of the bone samples might have looked like. And they're normally kept frozen and you thaw them out when you're ready to use them. I still remember leaving a whole set of samples out on the lab bench over a weekend, right? So not only did I mess up our study and we had to start the sample collection all over again, not everyone was happy when they came back from the weekend and they could smell those bone samples just hanging out. Then there was the summer that I worked with a graduate student and she was testing and breaking bone samples using a machine that looked a lot like this. And I was so excited to watch and I kept talking and talking and talking and I ended up distracting. She pressed the start button a little bit too soon and a component of the tester, the load cell, came crashing down. And it crashed down so hard that it got damaged. And it was so bad that she was in tears when she had to get up and go tell Dr. Unix what had happened. Okay, mainly because that damage would cost thousands of dollars, her system would be down for a couple of days. It's just, a complicated and scary thing to share with your mentor. So these were just a couple of incidences or experiences that made me feel embarrassed, maybe made me feel a bit stupid. But the biggest thing I would say during my undergrad years that I thought maybe research wasn't for me, I'm not really cut out for it, is that I felt like I didn't really have a project to call my own. I worked in an undergrad research lab for 4 years, and everything I did was usually just some kind of small task of my PI's project. Maybe it was a small task for a grad student's project. It just felt like all those things were really disjointed. I wasn't really learning much. What am I going to take away from this? But I just kept doing the research because I thought it was fun. I enjoyed doing it. And I realized that having some research exposure could help me down the line, whether it was to get a job, to go on to work for school. But I felt at the time that things were somewhat disjointed. Despite all of those experiences that didn't go so swimmingly, there were a lot of wonderful outcomes during my time doing research as an undergrad student. I applied to and received some summer fellowships. So this was one of the institutes that hosted a fellowship on campus. It was the very first one that I had gotten. And they gave me a chance to work with a professor on campus. And I still remember that they called and said, what kind of lab do you want to work in? And I had no idea. I just said, can you please not put me in a chemistry lab? Just because I'm not really good at it. And that's just how I got thrown into a bone lab to begin with. And I realized I liked it. I also got opportunities to present at research symposia, some that were like this, hosted on our campus, some that were more national. The Biomedical Engineering Society is a student-centric conference in our field, so I got a chance to go and present there. I also got a chance to write a paper. Interestingly enough, this paper came out 7 years after I graduated because these things take a lot of time. So overall, I think during those times, I learned some research tools and a couple of technical skills here and there. How do you use a microscope? How do you hold biological specimens? How do you work with data? Importantly, though, I learned that bone is even a topic that you could study. Okay, you can get exposure to new research areas if you just give it a try. I also learned that there's value in getting to know your professors outside of the classroom. They can teach you a lot in the classroom, but you can learn about their interests and the things that they're truly really passionate about in a laboratory setting. And if you get a chance to get to know them and what their interests are, you can get involved in that kind of work. I also learned there's an art to presenting your research. I don't think I necessarily learned it then, but I learned that it was valuable to try and learn it. I saw senior students, I saw professors presenting their research, and I realized that it's the type of art that you can and should try to learn. I also worked with a mentor who is approachable, and he had me work with graduate students who are also very, very approachable. And I realized that there's value in learning to communicate with your mentors so that that relationship goes both ways. Based on all the accidents I had in lab, I realized that attention to detail, working on a team, getting help from other people, that's critical in helping you grow as someone who's learning. And most importantly, I would say what I learned is that it's common for your undergrad research project to just be a small part of your faculty mentor's overall work. It might be part of a graduate student's thesis topic, and you're just helping with little bits and pieces of it. But even working on that small part of a project, it's still research, and you're still contributing to advancing that field. You're learning something new. It's giving you a chance to become a part of a research community. So with these lessons learned, I went off to grad school, and I started a PhD program also in biomedical engineering. And the way this worked out for me was that it happened to be a school I applied to for grad school. I didn't apply necessarily because of the research that they had there, but they had the department of biomedical engineering that wanted to stay in that general field. My mentor, Dr. Vishish, called me the summer or around the time I accepted and went to RPI, and he basically said, he works in a lab similar to the kind of lab I worked in as an undergrad, and that my undergrad advisor had recommended me to. And that's how that ended up happening. I basically went into graduate studies, still studying bone. The nice thing was that at this point, I knew a tiny bit about bone. I knew that you could study it, so I felt a little comfortable going into it. But while I was in his lab, I got a chance to learn some of the more technical skills that are critical to our research. So more fracture testing, more specific types of imaging, some biochemistry methods. Remember, I said chemistry was not my strongest suit, but I got a chance to learn that. And while I was there, my research in grad school also was not picture perfect. In my very first project, my goal was to compare group A to group B, two different groups of bone, figure out what the differences are. And my results looked something like this. There was absolutely no difference there. And I felt like my project was a complete dud. I was actually in tears a little bit because I spent an entire year working on this project. And I felt like I learned. In another project, I worked with bone samples from mice. And these mice happen to be 4 years old. Does anyone know how long mice live? Maybe 2 years tops. So getting samples from a 4-year-old mouse, that's something rare. It's very hard to do. So we have this amazing opportunity to study, for instance, how aging happens, how it affects bones. So I got so excited about this. And this is an image of what one of those mice bones might look like. I got so excited that I just took those mice bones. I started mechanically taste them. I broke them, break. But I forgot that crucial first step, which is something that I had actually learned as an undergrad. Image first, break second. But I broke them and I didn't take a single picture of them before I actually broke them. It's too late. So at this point, I still remember the day, Dr. Patricia came up to me and said, "Can I see some of those images?" And I had to look him in the eyes and say, "I forgot to take them." He was a little quiet, collect his thoughts a little bit, but I basically messed up a very important experiment, and it's something that we wouldn't be able to replicate because samples were so rare to begin with. And at this point, I felt like maybe I'm a disappointment to my advisor. Maybe I'm not really cut out to do research. But despite experiences like this, I still got some great opportunities. Oh, great. I have one more failure to share with you. I have so many things. So another memory that came back to me was one of the first conferences that we presented research at. And my advisor gave me this task. I want you to network. I want you to go talk to 3 professors, talk to them, and then come back and tell me what you guys chatted about. And I dreaded this because I'm pretty introverted. And I was almost a little annoyed at my advisor, like, "Why are you making me do this?" And so I remember being in the poster hall and there are people walking around. My advisor said, "Hey, that professor over there, he wrote that paper that you read a couple weeks ago and you were asking me questions about it. Maybe you can go ask him." So I dreaded this, but I knew I had that assignment that I had to do. So I walked up to him, and this professor, his name was Dr. Mitchell Schackler. And the words just came out of my mouth. My advisor said I had to talk to you.
Oh,
And I felt that was not the greatest first impression. But he laughed about it, and it just turned out he was a normal person who liked science just like me. And I didn't realize it then, but he would end up turning out to be a postdoc advisor for one of my own recent students who graduated and then went off to work in his lab. He became a mentor for them about 14, 15 years down the line from then. He also ended up being someone who wrote a recommendation letter for me when I submitted for my tenure 2 years ago. So you never really know where networking can take you. You have no idea when you might cross paths with these people. So despite some of these experiences that made me feel like I was maybe not smart enough or not doing a great job with this, which was pretty much all of grad school, to be honest, I got the chance to present my work. I got to learn how to talk about what I do. And one of these conferences or one of these societies ended up becoming my home professional society over the years because I got comfortable going there. I got a chance to publish papers, and I kind of figured out what I wanted to do down the line, which was I think I want to be an academic. So overall, I learned more research tools. Okay, that's important to my particular field. But importantly, I think I learned how to do research. How do you think about research? So remember this project that I felt was a dud, there's no difference. Well, I learned that, a failed hypothesis is still something that you can learn from. There's still value in that knowledge that you gain. I also learned that you have to be a little adaptable. So even though I couldn't really compare group A to group B, I thought, well, how does group A relate to group B? Okay. And I came up with this, and I saw that there was some kind of a relationship between these two. There was an interesting story to tell. We were ultimately able to write a paper about this, and it turned into one of the best papers for me that came out of school. So there was an interesting story to tell if you just look at it from a different perspective. On top of that, when it comes to telling a story, I think that's something that I also learned while I was in school. How do you talk about your science? Turn it into a story. You don't just have some methods, some results. You have a cohesive story of what motivated your work, what you did to pursue it, what results came out of it, and what those results tell you about the field of work that you are currently studying. So I learned that art of research storytelling from my mentor, who was amazing at it. He showed us by example how you can talk about your work using words that anybody in the room can understand. What also stood out to me about Dr. Vashish was how truly exceptional he was as a mentor. He single-handedly showed me the importance of having a two-way conversation with your mentor. He gave me good feedback. I had to learn to accept that feedback, and that takes some time. He was respectful of me and my time and my interests. He valued student opinions. He was willing to learn from students themselves. And for the students sitting here today, I would tell you to look for those kind of qualities in your research mentor, your future employer, having that two-way relationship can really help. So Dr. Fisher really was the reason I realized that I wanted to work with undergraduate students, and I wanted to mentor them because I could see what kind of impact he does for those students. So it was after I finished undergrad that I realized how important undergrads are to research. I had basically told Dr. Fisher one day that I was drowning in my work. And can we please get some undergraduate students to help me out a little bit? And I'll try to teach them some things along the way. And so we recruited undergrads to our lab. They worked alongside me, and my research really wouldn't have gone anywhere if it wasn't for the support of those undergrad students. I still remember fondly how grad students helped me as an undergrad, and I was able to now pass it forward to another group of undergraduate students. After this, my next logical step was to pursue a postdoctoral position. And to be honest, I didn't think I could go straight into academia. I felt like I had to do research for a couple more years before I'd be cut out for academia. And I had a little bit of a constraint. I had gotten married in my last year of grad school, and I was really hoping that I could get a postdoc in Boston so we could actually live in the same state. So after 10 months of applying, it took a while, I finally hit a position, and I worked with Mary Bucksine, who we very fondly call the Bone Queen. I didn't realize it, but she is one of the big guns in our field. Like, she does amazing work. She's flown mice into space to see how, mice bones might change when they are in an environment with no gravity. And she always just made the research environment so fun. This is actually a little GIF that we took with her at a conference. She's in the back middle. Like, she just made everything so lively, and it brought so much joy to the lab. And I really remembered this quality about her. So I didn't realize at the time how much I would be able to, look up to her as a scientist. She helped me get over my imposter syndrome. This is actually a picture of her on one of the many outings. She would take a lot of women scientists who were all just budding scientists, and she would take us there. And it was really motivating to kind of sit there and talk. During my time there, I had a lot of independence. I had some freedom to suggest new areas to study. And I also took on responsibility. I mentored students. Any mistakes they made, it was my responsibility, right? But things went wrong. I still remember, going through studies where, we had this one study where, we had to incubate some samples in a sugar solution. And the pH of those samples kept changing so much that we had to check it every hour. So what did we do? We started taking the tea back and forth all night long. We were trading off 1 hour me, 1 hour you for several weeks to make sure that this wasn't a total flop. I worked with patients, and I had to deal with their medical records. And I remember misplacing a medical record once, and I had to deal with the responsibility of reporting it to make sure that, this issue didn't happen ever again. I also helped on animal studies. I still remember when I was learning to work with a mouse. I once had a mouse on my hand, it squeaked, I dropped it. So we were all on our hands and knees just trying to catch that mouse over the course of 2 hours. So these were all experiences where I made a lot of mistakes, and I oftentimes felt embarrassed over the years, but I had successes. I got chances to present my work. I got a chance to publish papers, I wrote grants. And because I worked so closely with students, I became the go-to recruiter for undergrads in our lab. So overall, I felt like I learned research tools, but importantly, I got my feet wet in learning how to manage research, how to complete it from start to finish, and how to work with students who were helping all those projects. And because of all those mistakes I made, I became a little bit more thorough in planning and organization. During this time, I also realized I went from a bone lab to a bone lab to a bone lab. Okay, and I needed to expand a little bit outside of it. So I started writing grants, and I remember writing a grant that actually was designed to teach you new techniques. So I had to take initiative and make an opportunity for myself where I could try to learn something new that is beyond just bone. Another way I learned to take that initiative is realizing that there was no opportunity in that hospital setting for me to learn how to teach. And I wanted to ultimately teach one day. So I called up professors in Boston, and I said, I want to learn how to teach. Can you please let me guest teach in your classroom before I actually become a teacher? So you have to take initiative, try and create some opportunities for yourself. But most importantly, I realized during this time that my desire to teach and work with undergrad students was very valuable to me. I saw myself doing that down the line. I kept working with undergrads because it was so valuable to me. And as I mentioned, I was the undergrad recruiter in our lab. I interviewed students, I filtered through their resumes. And honestly, as an undergrad, you might not have a lot on your resume just yet. This might be your first experience doing research. So what we looked for was motivation, willingness to work, okay, willing to be a hard worker. So I was responsible for trying to figure out who those students were. And also, when we had these students join us, it was important that we gave them credit where credit is due. So we would write papers, okay, but we would make sure that those undergrad students were all involved and they got authorship for their experiences and their work. So ultimately, these experiences brought me to where I currently am. I'm a professor who does research. I teach in the classroom, but I also teach a little bit outside the classroom. So I applied for faculty jobs for a good 2 years before it worked out well. And at this point, like, I couldn't be happier that I am at UMass Dartmouth. It's been such a great experience for me. And importantly, something that is very near and dear to me is that we have a lot of students who are experiencing college for the first time. I have many students who are first generation college goers. I have many students who are students of color. A lot of our students are working full-time jobs, paying their way through school while they're also trying to study and do research. So I tried to create a lab that is welcoming for students, particularly undergrads. And I would say in my 8 years, I was trying to count this up the other day. I would say I had 3 PhD students, 13 master's students, and somewhere around 55 undergrad students who came through the lab. So our research would literally go nowhere if it was not for the undergrads who became part of our team. This is a picture of the first cohort of undergrads who came through. So these experiences also kept growing my love of working with undergrads. So in addition to my own research lab, I'm now the director of the Office of Undergraduate Research. Our goal is to support and promote students doing research, scholarly work, creative activities. We provide and share opportunities for them. We point out fellowships outside of campus. We offer them some fellowships on campus ourselves. We try to showcase the very talented students who are doing work on our campus. So during my time in this office and drawing from my own experiences as an undergrad and later on in life working with undergrads, my thoughts on why you should stick with research as an undergrad is that at this point, you should at least start thinking about what you want to do then. Sometimes I think I'm still trying to figure out what I want to be when I grow up. So you might not have it figured out yet, but it doesn't matter if you want to be a scientist 20 years from now. It doesn't matter if you want to be a professor or not. My goal is not to convince you to be a professor. You have to be a scientist. But you all have different aspirations, whether it's going into higher ed or you want to be an engineer or an artist or a writer. But regardless, the value of you participating in research and taking initiative to learn something can help you pursue that future goal, whatever it might be. You're going to learn how to solve problems and create. You're going to interact with faculty, students, collaborators outside of your university. You might develop some analytical or technical skills. The fact that you can learn how to pick up those skills, that is a value that you'll take on afterwards, even if you're not doing research down the line, even if you're doing a different kind of job, the fact that you can pick things up in a lab, that's a skill in itself. So during this time, you can take initiative, learn to work with people, but basically you can show your commitment, your work ethic, and your perseverance, which is very attractive to future employers, future mentors. Okay. I have so many examples of undergrad students who have mentored, who have worked hard and persevered. So this is a picture of one of my first undergrads, Jake. His project had never been done before, and his job was just to keep trying this method until you can get something to work. And he stuck to it and he made it work, and now he's an engineer at Abbott Labs. My student, Matt, he loved graphics and design, and he would keep coming to talk to me, say, I want to learn this. I knew nothing about graphics design until one day I said, here's a book on SolidWorks. Do you think you can learn it from the book and then you can teach it to me? So he did. He spent a whole year trying to learn this, this computer-aided design program. He started designing things for a lab, and now he works for Dassault, which is the company that develops that software. My student Landon, I gave him a project that I typically don't give undergrad students because it required these very, very meticulous methods that are often really challenging if you've had many years of experience. He took it in stride and he would ask the people questions and he would seek out answers even outside of our university. And now he's a grad student at Brown. And then here's another example of my student Tiana. Her project just did not go well. It just nothing worked. All the methods failed. She took some extra time trying to finish her research project, but she stuck to it and she finished it. She worked her way up in companies. She started in sales for scientific products, and now she's a senior researcher. So their hard work has truly paid off. These students have tried new things. They found a mentor that they could talk to. They networked. They made opportunities for themselves. So these students have truly shown me that through their hard work, they can succeed at something. And if you don't at least try it, you can't really succeed at it. And that failure is part of success. I feel like these students truly demonstrated that to me when I worked. So taking all of this into consideration, if there's one thing that I want you to take away from this talk is that research is not necessarily what you might envision, what you see in the movies. So this little comic here, if you look on the left, the comic shows how easily scientists can pick up a speck of dust and use all sorts of high-tech equipment and figure out exactly what it is within seconds. But in real life, what you see on the right, you might just be doing some of the small stuff and figuring out bits and pieces, and you barely go anywhere because it takes, 20, 30 years for your research to really contribute to something. But that's okay, and that's research is complex and might feel a little bit monotonous or a little boring, or you might not know where you truly fit in. But if you stick to it and commit to that life of learning, whether that's learning technical skills or soft skills or how to build relationships with people that you work with, as long as you stick to it and persevere, that work can all pay off, regardless of what you're doing. So with that being said, I just want to acknowledge, started listing all the students in my lab, didn't have enough room, but these are just some of the students who have kind of propelled our work forward, my mentors who helped me get here, people who have worked with me. So thanks so much for letting me share this, and I'd be happy to take any questions.
You are so inspired. Absolutely. And is this on? Yeah, there we go. I have a million questions, but we're going to open it up for folks. But I want to give folks the opportunity to again ask a question or even sort of reflect back or any thoughts on the presentation. But I did want to note how important the issue of mentorship is. I mean, it's incredible how it makes a big difference. To be engaged with a faculty member, but also colleagues that are peers, as well. And I just feel like that's one of the things that really sort of transforms our academic experiences when we're undergraduates and graduate students and faculty. Even as faculty members, we're still mentored and still receive that kind of connection with other colleagues. I was wondering if you could, so just give you all some time to think about a question or sort of comment. I was wondering if you could sort of just maybe what is the one thing that those faculty really sort of demonstrated to you in terms of the care and mentorship that they showed to you over the years? Like, what is the thing that just really stood out that was just like, this is the thing that, and I saw multiple things, but what is the thing that stood out for you?
That's a great question. I honestly think what stood out to me about my mentors, and I was lucky to have some really great mentors, is that they let me see that they were very similar to me. They had similar experiences at me. They might have been 30, 40 years out from where I was at that point, but they all had similar experiences. So they understood what it was like to be in their shoes. And I think that helped a lot.
Yeah, they also seem to show a lot of care, right? And sort of like really being rooted in a way that makes a big difference and accessible. So any questions from the audience? So one, I saw a hand over here too. Yeah. Okay. Okay. Oh, you're like, hi. Yes. If you can introduce again, my name is Dr. Mari Castaneda. I'm the Dean of Commonwealth Honors College. Thank you all for being here. And if you can introduce yourself.
Hi, thank you so much. Scott Auerbach here from UMass Amherst. And so first of all, thank you for that amazing story, inspiring story. And you're right, you tell a great story. So thank you. one of the things that in my advising that I face with students is the question of when you told the story about making, you're in college, then you're choosing. So there's a lot of choosing. So you're choosing to work with somebody, then you're choosing a grad school, then you're choosing an advisor, then you're choosing a project. And in that choosing process, and if we're lucky to have choices, there seems to be there's a lot of stress that students feel associated with those, choices. Am I making the right choice? And one of the things that I try to share with students is that, well, there can be a lot of right choices. It's just that these choices will color your eventual career path. But it doesn't mean that you're choosing between a good and a bad choice. So I wonder if you can share some of an example of the choice that you've made that was maybe a difficult choice, but that in the end sort of, worked out.
That's a wonderful question. Thank you. I would say one of the difficult choices was later on, I ended up doing a postdoc. That was at a hospital. And I think by this time I had figured out that I want to be a faculty member at a traditional university, and a hospital did not necessarily lend itself to the kind of environment that I necessarily needed to pursue that. So I had to I think partway through I realized, oh no, I'm working in the hospital. I'm not going to learn how to teach and work very closely with students because I'm mostly surrounded by medical doctors and a team of senior scientists. Their goal is to just churn out data. Whereas at a traditional university, my goal is to kind of work with students and let them learn. Research goes much slower. So I think it ended up working out because I recognized that might not have been the right setting, but I had to go out and find some opportunities for myself to be able to learn the skills that I needed to go on to that next stage. Yeah.
Thank
you.
Well, the other thing that I thought was really great about the presentation too is that a lot of those lessons learned myself as someone that does more social science and creative practice and also community-based work. I'm not a scientist at all. I don't do the bench science at all in my own work. But so many of those lessons were totally relevant, for the kind of things that we're thinking about in terms of research, and research really being about investigation, inquiry, really thinking creatively about what is it that I'm interested in and how can I figure that out, whether it's, again, I do also a lot of work on filmmaking. And so there's a lot of collaboration that takes place with that and a lot of inquiry of how to tell the story, as well. So I just felt like that was absolutely relevant to so many of the fields outside of the area that you're working in, biomedical engineering as well. So I hope folks saw that too, because I felt like it was very, very clearly connected to other fields also. Any other question? Yeah. You can introduce yourself. Be great.
My name is Hannah. I'm from Quinsigamond Community College. And I just wanted to say that in this digital age where we all have Instagram accounts and everybody's kind of showing off this highlight reel, it was very refreshing to see somebody come to the stage and kind of normalize failures and share maybe some moments that don't shine so brightly, but that's
That's a great comment because it's true. Oftentimes it's rainbows and roses all the time. And the reality is that it's not all the time, but how do we then persevere to get to the other side and to really be transparent and honest about that? I think is incredibly refreshing. You're absolutely right. And that's why I'm also so excited to see all the posters that are going to be, I'm just let's get up there to see all the work. But we have time for one more comment or one more question. And please introduce yourself.
Hi, my name is Liz Green. I'm from MassURC. And I wanted to know, in your undergrad, you studied bones and still study bones now. And I wanted to know, if you had started in a different lab, in a different project, do you think you still would have found your way to the research that you're doing now?
Not necessarily. For all I know, I could have been researching something completely different. I think it turned out for me that I started in bone and I just thought it was interesting and I stuck to it. But I know so many other fellow students of mine who started in completely different areas and they do something completely different today. I know someone who, he started off working on heart tissue in animals and Today, he does nothing related to hearts or working with animals whatsoever. He researches hearing. Like, it's a completely different thing, but he could still take away some lessons from that. It gave him the opportunity to learn how to do things, how to work with people. So it's not necessarily that you're gonna stick to the same thing forever, and you don't have to. So it's very possible that if I started doing something else, I might have just gone down a completely different track. And you had mentioned that, you know, there's so many different possible right tracks. It's just my path happened to go one particular way. But it's very possible I could have ended up somewhere completely different.
So we want to give folks the opportunity to also speak with Dr. Kareem. You know, 'cause sometimes it's nice to have like the one-to-one here, and also give folks the opportunity to network, engage. You know, of course, we have lots of refreshments, so we'd love for you to all enjoy those as well. But if there aren't any other final comments, because I know folks have to get ready to set up posters and get ready to do those wonderful presentations that we're going to be seeing in the campus and auditorium, and then the other poster session. So we can give one more round of applause to Dr. Kareem. I hope everyone continues with their research life and academic life, because again, it's wonderful to be creating new knowledge and new forms of being and living in the world. So congratulations all for being here, and also to the mentors and faculty that are supporting our wonderful students from across the state, because without you, our students also won't have those experiences. So thank you all for being so wonderful with our students from Massachusetts. So go MassURC, happy 30th anniversary. Everyone, look forward to the day and the reception, 4:30, Commonwealth Honors College Events Hall. If you're still here, join us. Thank you.
It's just in the middle.